Everyone, welcome back. We're going to finish off 2.3 today. So 2.3, complex numbers, part 2. The essential question is, how do I simplify complex numbers and imaginary numbers so that they are written in standard form? First thing I actually want to review is yesterday, over the weekend, we talked about how I is equal to the square root of -1. Meaning that I squared is actually equal to -1. Now, that's all we've been exposed to so far, but we've got to know that the exponents aren't always just 1 and 2. So if I were to get I3, that would be the same thing as the square root of -1 times the square root of -1 times the square root of -1. Okay? So we know that the square root of -1 times the square root of -1 would give me -1. The square root of -1 can be simplified as I. So -1 times I is going to be -I. Okay? Same thing for I to the 4th. If I were to write out all of this, I would get square root of -1 times square root of -1 times square root of -1, so on and so forth 4 times, until I end up with -1 times -1, which would be 1. Okay? There's probably an easier way, and you can do that by using your rules of exponents. So if I were to remember just these 4, I would be able to finish out the pattern. For example, I to the 5th is the same thing as I to the 1st times I to the 4th. Now, why do I choose I to the 4th? I choose I to the 4th because I to the 4th will always be equal to +1. So, in reality, I'm just multiplying whatever this guy is, I to the 1st, times 1. Which means that I to the 5th actually just simplifies to a single I. Alright? And now there's actually a pattern to this. If you want to write this down, feel free. We have I squared, I cubed, I to the 4th, I to the 5th, I to the 6th, and I'll go down to the 8th, and it will continue on in the same pattern after that. So I to the 1st power simplifies to I squared is -1. I cubed is -I to the 4th is +1, and then we restart our pattern here. I to the 5th becomes I to the 6th, -1, I to the 7th, -I, and I to the 8th, +1. So it actually follows this pattern all the time, and if you want to think of it as the I1 pattern. So I1, 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 I1. If that helps you, feel free to memorize that. I'm going to go ahead and start off with some examples now. So example 1. We're going to simplify some pure imaginary numbers so that they're much nicer than the big exponents that we deal with. So simplify I to the 10th. Using my rules of exponents, I want to break this into very simple parts. As part of 10, I know I can break it up into I4 times I4 times I squared. Now, why is that true? Because 4 plus 4 plus 2 would be 10. Remember that when you multiply something with the same base, you just add the exponents. So now this simplifies to 1 times 1 times I squared would be -1, which means my answer is -1. I to the 10th simplifies to -1. Okay, now I'm going to go ahead and start example 2, in which I actually have some addition involved. So 3I to the 7th plus 2I to the 6th. Once you get used to the pattern, you can actually probably just do it without having to work it out. I will show the work in this one though. So I'm going to break up I to the 7th into I to the 4th times I cubed. Then over here I have 2 I to the 4th times I squared. Again, I 4th just simplifies to 1, so I'm not going to even bother with it. Instead, I have 3I cubed. I cubed would be -1, or -I mean. So this is going to become -3I. Over here, I squared simplifies to -1. So this is actually going to be plus -2. Remember that we want to write it in standard form, a plus bi, so I'm going to rewrite this as -2 minus 3i. Okay, so that would be the standard form answer for all that. I'm going to go ahead and take a quick break here because the next part is going to be involving conjugates and complex numbers. So actually I do need quite a bit of room for that for the example after. So here let's just go ahead and start the notes for conjugates. No need to change color, I just felt like it. So conjugates, let's have a plus bi over c plus di. Now we're going to be multiplying by a conjugate. If you guys remember back to rational expressions and radicals, we had to rationalize the denominator by multiplying by the conjugate. The purpose was at that time to get rid of the radical in the denominator. The purpose here though is actually so that we can rewrite this entire thing in standard form. The way it is right now, it's actually not in standard form, and that's not how we want to write a complex number. So in order to write our conjugate, we want to take our denominator and take the opposite of the second term. So the conjugate would actually be c minus di. So in that case, I'm actually going to multiply this whole complex number by c minus di over c minus di. Okay? So as long as you can remember why we do that, you also remember that conjugates is just like before, where we take the opposite of the second term. Okay, so with this, I'm going to go ahead and turn the page, starting on my final example. Set this up real quickly. So let's go example 3. We're going to have 3 plus 5i all over negative 2 minus 6i. So first off, I need to identify my conjugate. In this problem, it's going to be negative 2 plus 6i. So remember, you're only changing that second term, not the first term, even if it's negative. Okay? So with this, I'm going to multiply at the top and the bottom, numerator and denominator, by that lovely conjugate of ours. So negative 2 plus 6i, negative 2 plus 6i. Now you guys can feel free to multiply whichever way you want. You may use FOIL, you may separate it so that you multiply each one. As always, I'm going to stick with the box method just because it helps me organize things a lot nicer. So here I have 3 and 5i, and then negative 2 and 6i. Negative 2 times 3 will be negative 6, negative 2, 5i, negative 10i, so on and so forth. So let's fill this in. 30i squared. Remember, if you end up with an I squared, you do need to simplify that so that it becomes a negative 1 and multiply it with the number in front of it. Let's go ahead and do the denominator as well. I'll make a note of that to myself. So there's a numerator, and this is a denominator. Okay, so this one I have negative 2 minus 6i. Over here I have negative 2 plus 6i. The nice thing here is that when we multiply it, we're actually going to get some stuff that cancels out. So here I'll get 12i, here I'll get negative 12i, and here I get negative 36i squared. Okay? So in a very nice manner, these two cancel out, and we're going to see that these two will be like terms because our I squared becomes negative 1. Alright, so let's go ahead and rewrite this. All of this will go on my numerator, so negative 6. I'm going to combine like terms right here. I'll do that in red, so it's going to be plus 8i. Then I have plus 30, but because I have I squared, that's going to become a negative 1. On the bottom, I have 4 minus 36. Again, I squared becomes negative 1. Okay, so here this is going to be negative 30, here this is going to be positive 36, so let's rewrite it. Negative 6 plus 8i minus 30, and then 4 plus 36. I'm going to go ahead and simplify now. So over here, negative 36 plus 8i, and just like I said it would, it becomes a nice real number, 40. At this point, we want to go ahead and simplify as much as we can, so I'm going to break this up into two separate fractions, so negative 36 over 40 plus 8 over 40i. Make sure to have I off to the side. That's going to be our proper notation for standard form. At this point, just simplify your fractions. This is negative 9 over 10 plus 1 over 5i. Right? And that is our simplified form of this really complex number in standard form. Alright, so we went over a lot. Go ahead and rewind, replay as needed. Come with questions. Make sure to write steps. And have a good day, you guys.